Hi there, I'm just here to do a quick tutorial on how to use the new debugger inside our virtual machine. I have a little terminal pulled up here, and we can jump over into that terminal and quickly look at the files we have accessible to us. There's this handy little test.c program that I'll use to do a quick demo of some simple GDB features, and then we're going to jump into looking at the first stage of Lab 2, which may be useful to you when you start working on that yourself. So here's our little test program. It prints hello world. You may have seen something like this at some time previously in your life. We're going to compile that, but we're going to add the special flag G for adding debug informations. I know debug doesn't start with G, but it does end in G, so small, favors. So we're going to compile that, and then we have this a.out file. We're going to run that in GDB, the new debugger. We're going to put a breakpoint at main, the method that we definitely have, actually a function. And we're going to say run the program until that point. Now it's going to stop here, and we can say, let's see what the source code looks like. Say list shows us all our source code. We can also look at the assembly code that actually executes each of these steps. There's a number of ways that we can look at this. We can step through a single step of the C code. We've already printed hello world now, and we're about to return 0. Now, what if we didn't have all that handy debug information? What if instead we had compiled it, maybe accidentally, without the debug information, left our source file at home? So we can now look at this new a.out compiled without debug infos. So we'll again break at main, run the file, and what if we try and list? Well, there's no symbol table listed. We don't have the debug information. We can't look at our source. We can still look at our assembly, and this is going to be true pretty much regardless of what you do or don't put into your file, which is a little detail that will come in extremely handy in Lab 2. We have also this mysterious executable file called bomb. We don't know what's in it. We can run the disassembler against, or the debugger against it, but if we try to list the source, we don't have any of it. So this is a small difficulty for our debugging, but we can, I've learned from my sources that we may have a method called phase 1 somewhere in this bomb. And look, there it is. If we try to break against a function that doesn't exist, it's not going to do it. So there definitely is a function called phase 1. If you also try to look at the current assembly code being executed before you start running the program, you're also not going to have any luck. Alright, so let's go look at this phase 1 program, put together by a madman, I see. So what is something that we could recognize in assembly code? Often programmers like to use words like foo and bar to easily detect them later when they turn up in their tests, but they're not particularly obvious if they're not represented as strings. So maybe we should use something that we can definitely recognize, like a whole bunch of A's. All the A's will be represented the same way, and we can definitely see them later. Alright, so we'll put this input in. Now we've hit our breakpoint. Well, again, we can't list. We don't have any source. So what if we disassemble instead? Alright, here's some assembly code that looks pretty interesting to us. Pretty familiar, too. GDB, by the way, has a vast amount of help. You can get help on pretty much any topic you're interested in. And then once you look at the help for it, you can get help on your help. So for instance, if we want to look at help info, it gives us a whole bunch of different commands that we can do with info. We can look at sources, we can look at records, we can look at, well, in this case, I guess we can't look at sources, can we? But we can definitely look at registers. So here's our SP, which you may already have learned is the stack pointer. This is pointing into the stack. Here's our IP, the instruction pointer. See, here's the name of the function that we're inside of. RAX often holds a return, and the first two parameters to a function will often be in RDI and RSI. Certainly in a 62-bit machine like this one. 62? Goodness. Certainly in a 64-bit machine like this one. Alright, so we'll go back to our assembly code. If we take a step, like we did before, we're going to run all the way through the single line of execution in the source code and blow up the bomb. So instead, we're going to type all those A's back in, and we're going to take one step, instruction by instruction. So now, if you see this little arrow on the screen here, this is pointing to the function or the instruction that we are about to execute, not the one we've just done. This one in particular is pretty interesting. We're about to make a call to a function called strings not equal. Well, that sounds like the kind of thing that we might care about. So let's look again at these registers. And it looks like there's a little more going on here than there was before. So you may recall that we can look at what's on the stack. That could be interesting. Looking at the stack in GDB can be a little bit complex. But basically, any data source that you want to look at, you can type this X, and then what we're going to type in is in the format number of units that we want to look at, and format, how we want to see this data represented. If you just type it like this, it'll get confused. It doesn't understand what you're talking about. So we say X, we're going to look at, let's say 24 words, quad words in this case, let's say hex. Everybody likes hex. And we're going to look at it on the stack, so we'll say RSP. And here we have all of the things on the stack. And you'll recognize this address from previously when we looked at RSP to see where it is. All right, great. But the stack isn't too interesting to us because we're looking at a 64-bit program, so it's going to be putting its arguments to this strings not equal function that we're interested in right into registers. Well, specifically the registers that we're interested in are likely to be the first two registers that arguments get stored in. So again, we can look at this X, and we can say we'll look at 2 words maybe, and we'll represent them in hex, and we'll look at the first argument register, RDI. Oh, that's a bunch of 61s. It's almost as if a single value is being repeated a bunch of times, like those A's we typed in. Now, if there's an easy way that we could look at them, that might be better. We could say, let's look at these as strings instead of as hex numbers. Oops, RDI, sorry about that. And look, there's our A's. You can also look at them as integers, which is not particularly useful for us right now. By the way, just a quick tangent, I know that the way we're representing registers in GDB is an awful lot like the way that assembly represents constants. This is an unfortunate but true fact that you're just going to have to get used to. It can be a little confusing at first. If we try and tell it to look at a register using the assembly code method of a %sign, it's not going to know what we're talking about. I'm not sure why they decided to do it this way. They just did. All right, so let's look at that other register, because we already found our input, but what could we be looking to see if it's equal to? Well, we could say, let's look, and it's looking for strings not equal, so we probably want to look at them in string format. And we'll look at RSI. Oh, now there's an interesting string. I'll put a couple breaks in so that you can see it more clearly higher on the screen. Well, I didn't type that string in, so I wonder where it could have come from. Maybe it's important to look at in hex. 59, that doesn't look nearly as meaningful, but let's copy it. Oops, that's the wrong kind of copying. Copy it, and we'll leave GDB so I can show you really quickly one last feature of this bomb that we have prepared for you. You can look at a text file, Defusertxt, and we can paste in this value that we've just received. and we can run this bomb. First, let's just run it without any input. We say foo-bar baz. I know what computer scientists like. That's not the key. All right. We'll say bomb Defusertxt. Well, that's not the key either, but you see that I didn't need to enter any input. It's taking the input from this Defusertxt file. So is there any input that we've seen earlier that might actually be the key to this bomb? You should check it out.